Okay, thanks everyone. So look, everyone here I think probably does know me anyway. Michael Goggin, I'm the Senior Design and Applications Engineer in Expo Process Analytics. There's been a lot of presentations today already on the Microsolis, which is the new flagship product that's been going forward. But as JP would have alluded to in kind of opening, the Taso is probably one of our longest run. Actually, I think it is our longest running device. There's the most of those units in the field. And we are aware there still is a lot of legacy there with those. So over the last 18 months or so, we've actually done quite a lot of redevelopment to get the next gen Taso and Rado devices ready. So this is effectively where we started. We redesigned a lot of the actual internals, make it far more robust. We did a hell of a lot of testing. I think this was some torque testing we did. But anyway, we spat out some devices at the end. So it is just a quick summary of a lot of the stuff we've done. For anyone that's seen the inside of the legacy Tasos, this has all effectively been replaced. Because of the high precision elements and fine particle sizes, we've effectively removed any welding from the housing to reduce any risk of thermal distortion. So faces would sit flatter, you wouldn't have any powder particles getting in where they wouldn't. The offset drive mechanism, which is what's highlighted here, has caused a lot of problems. You've had spur gears, you had grub screws, you had alignment issues. So all that's effectively been removed. Lever arm position is the second part there, and the grub screw is the third part. There's also a single spring that kind of applied the force back on the unit, which again it worked, but you didn't get even distribution of the wiper performance. The wiper material was GF25 PTFE. Pharma grade PTFE is widely accepted, but virgin PTFE we found was too soft. The wipers wore very quickly. GF25 PTFE just scratches the front face of whatever device comes in contact with it, ends up being too hard. And then we did a lot of testing on the wiper performance itself. So breaking it down, the revised housing and chassis design. So the probe bore here is now modularized so that it can be changed depending on the probe configuration that's being used. So our default is a 3/4 shaft probe, but you could integrate sapphire windows into the front of it if you were using maybe non-contact applications. You could technically make the bore smaller if you were using a smaller diameter probe. We've added dowel pins for kind of improved alignment, additional bearings to true up the actual shaft perpendicularity to the front wiping face. We've also looked at the heating blocks, so you can actually heat up the front face of the device, again, to aid with moving powder and wiper performances. And a revised PCB board for anyone that's sort of seen internally devices before. This makes it just far easier to assemble the devices. And then from a serviceability perspective, we've got this kind of nice kind of outer cage effect, or skeletal cage, and then an outer case that actually slides over the front of it, so it just makes servicing these units far simpler. The direct drive, this is where a lot of the headaches would have been historically for units in the field. So we've removed all the lever arm, the spur gears, the grub screw for effectively a direct drive. So our little pneumatic motor inside in our Taso now has got a D-shaped keyway, and it slides directly onto the driven shaft. So there's no spur gears, no misalignment issues. The referencing, position referencing is also now it's integrated into the motor itself. So there's no lever arms aligning with magnetic sensors on the PCB board, which is how it used to be run. And then we've actually got a multi-spring configuration. So in this cut section, you can see there's this round component, which actually has 3 springs, 120 degrees apart. So you've got a more even spring force, effectively pulling this shaft back and pulling the wiper onto the front face of the device. And it's mounted against a bearing to make sure, again, that it's all sort of screwed up and you've got that spring force acting in the plane that you want it to. So it's running along the axis of the shaft, perpendicular to the front face of the device to improve your wiping. The shaft sealing, which is another point. So you'd be getting additional resistance, you'd be getting premature failures with some of the kind of rotary O-rings. So they've been replaced with Garlock rotary shaft seals. Similarly to the legacy Tasos, they are still supplied with all the material traceability certs and everything that you would expect for them. But we've just swapped them out for more suitable ones for the application. We've also done some testing on these where we run the device, measure the seal pre and post running, see what the actual wear and rate of the seals is, and then we can extrapolate our actual service intervals far more reliably with these. But yeah, they're still rated to 10 bar pressure, CIP SIP compatible, and yeah, good dry running, so no lubricants or anything required there. The wiper installation, once you kind of get the knack of it, you could do this on the legacy Tasos, but it's like 2 pieces of a jigsaw puzzle. They don't go together very easily or very smoothly. So that's just been simplified. Two halves just kind of slide in directly and they're retained on pins. So it just makes it easier. The wiper material itself has been altered to ultra high molecular weight polyethylene, which is some of what Uwe was speaking about in his presentation with the microsolace as well. I think on sort of a case by case basis, look, we can still supply these in GF25 PTFE for legacy situations and that kind of thing. But from a PFAS perspective, we're trying to move away from it. And additionally, we just found that actually we did wiper performance testing with both materials, and you're getting improved wiper performance with this material. It's slightly softer than the GF25 PTFE, so it'll form a bit better to the face and wipe better, but not as soft as virgin PTFE, where it sort of wears and you end up to replace the wiper far too frequently. And then just optimizations. So some of this we have actually gone through in the lab demos, but effectively we recessed. So this is the probe bore. So we've recessed that kind of front probe seal behind the lip. So effectively now the wiper is going to be running across an entirely uniform surface. You don't have any sort of inconsistencies where, depending on the seal that's installed, it's proud or recessed or anything. We've got the probe setting tool, which we would have gone through on the microsolace, but it's the same unit that's compatible with the Taso as well. And then, yeah, the alternate wiper material is just like what I've gone through. And then this is effectively just the very quick summary of effectively all of the testing we've done over about 18 months to make sure that there is robustness in this next iteration of these devices. So various prototype builds, wiper alignment to make sure we're getting that perpendicularity between the wiper and the front face. IP testing to make sure it's still IP65 rated. Torque testing, so we've used torque transducers to actually track exactly what torque was required to drive the various powder blends. Endurance, where we would have run it for, I believe it was 2 weeks solid to make sure that there was no issues with it. Face immersion to make sure all the seals did their job at the front, and then your actual wiper efficacy, where we would have assessed the performance of the wiping. And yeah, that really is a 5-minute presentation. I don't know if I've even gone over 5 minutes, but these are just some videos of some of our very, very rough tests. First one was very early days, but just to show the kind of improved torque, that the actual wiper could actually lift itself up, so no more kind of getting caught. Second one was actually a Rado device, which has just kind of got a flat wiper, but it's the same mechanical configuration internally as the Rado, and it works, as the Taso, and it works in the same way. We just had it inside in a funnel, effectively here, full of powder, and making sure that it could wipe back and forth like that. I think that was actually part of the endurance testing, where it would run submerged in a pot of powder for about 2 weeks. And then these are just some tests I would have done recently, just with different pharmaceutical blends with the Taso, much lower flow rates than you'd get in the microsolace, or that would be the intention anyway. But I think that one was actually lactose. This one I think was APAP. But again, just proving that you do get your slightly better wipe performance, your higher speed, your better allowance than you would have had with the legacy devices.